Look around you, whether it's a car, a massive excavator, a factory conveyor belt, or a simple elevator. Every single machine on earth does the exact same basic job. It takes raw energy, multiplies it, and transforms it into useful motion. Today, we are stripping out the outer sheet metal to look at the fundamentals of engineering physics that make a machine work. The absolute first requirement of any machine is moving power from where it's generated, like an electric motor or an engine, to where the actual work happens. This is called power transmission, and its primary weapon is shaft. A shaft is a precision metal engineered to transmit rotational force, which we call torque. But when a machine needs to alter its speed or change the direction of that rotation, it relies on the gears. Think of gears as a mechanical team. When a small gear spins a large gear, you trade speed for raw lifting power. If you have ever wondered how a machine can lift a 10-ton load without the engine stalling, it's all down to the mechanical logic of gear ratios multiplying force. If you have heavy metals spinning at thousands of revolutions per minute, you run into the ultimate enemy of any machine: friction. If left unchecked, metal on metal, friction creates extreme heat that will literally melt your components together. To solve this, machines use bearings and bushings. A bearing acts as a smooth buffer between a spinning part and a stationary machine frame. By using tiny, hardened steel balls rolling inside a smooth track, it changes sliding friction into rolling friction. This keeps the movement completely effortless. Along with bearings, machines use lubricants and filters that keep the thin film of oil between moving surfaces, catching any tiny metal dust particles before they ruin your components. Sometimes mechanical gears aren't enough to deliver the immense linear force that is needed to smash through a rock or lift heavy steel structures. That's when machines switch from mechanical linkages to fluid physics using hydraulics and pneumatics. The mechanism here is remarkably simple but incredibly powerful. That's Pascal's law. An engine drives a pump that pushes pressurized oil or compressed air through high pressure hoses into a heavy steel cylinder. Because liquid cannot be compressed, pushing oil into that cylinder forces a solid steel piston outwards with thousands of pounds of pressure. This is the raw muscle behind earth moving equipment and automated factory presses, giving a single machine the strength of hundreds of men. Finally, a machine needs a skeleton to hold its muscles and backbone in place, allowing parts to move in controlled path. This is handled by pins, bushes, and linkages. Think of pins and bushes like the joints in your own body. They create clean pivot pins that connect major structural parts, like a loader bucket to an arm. They ensure that while the arm moves up and down smoothly, it remains rigidly locked in place side to side, preventing structural twisting and dangerous misalignment. What is the core mechanism of a machine? It is a beautiful design of physics. Shafts and gears carry the power, bearings eliminate the friction, hydraulics provide the muscle, and precision pins hold the structure together. When even one of these components fails or wears down by a fraction of millimeter, the entire physics equation changes and the machine's efficiency decreases. That is exactly where we specialize in manufacturing and servicing that exact core building blocks right in our workshop. From heat treated spline shafts and high pressure hydraulic hose assemblies to precision grounded pins and customized seal kits, We build the pieces that keep the machinery of modern industry running flawlessly.